Hello and welcome back to compiler programming. In the last video, we did a majority of the work for the imports. In particular, now we can have multiple libraries imported and have any number of functions from those libraries also available to our executable. Obviously, we're not using them yet, but before we jump into using them and generating this assembly code, one final preparation step I want to do for the encoding of PE32 executables is to try to flip around the RData section and the codes section. And the reason I want to do that is so that we don't have to do patches to the code. So if you think about it, these imports, they are not dependent on the code that we write. They are only dependent on the sort of like how many things we import inside the code. And the way we structure in the future the parser, we could pretty easily make it such that we gather up all the imports of our code ahead of time before we start to generate any assembly, and that would mean that we can write out this whole executable in more or less one pass, which is pretty neat. But trying to do so may cause some issues, so let's go from the top to bottom and figure out what we need to change if we want to try to switch around these sections. This is fine, size of code is fine, this is interesting. I think the size of initialized data is actually should be 200. So let's check if that is true. Okay. Yeah, so this is something we can switch because right now 200 is our file alignment, and we should know that all of the imports fit into that list right now. In the future, we of course need to calculate it based on the imports and any other data that we put in a global scope. Okay, address of entry point. This is the first thing that needs to change. And for that, I will even start to introduce a variable, and I will say something like S32 code base of code is this, and then address of entry point relative to base of code is 0. Because this is something that we would get out of our compiler eventually. We will not get the absolute position, but we will rather know inside of our code how far along is the first instruction that we need to execute. So if we try to do this now, we can say that this would be base of code plus address of relative address of entry relative to base of code. Okay. Now we change base of code. Section alignment is something that we'll need to use to calculate this stuff. So maybe let's add a comment, use section alignment. Okay, this is good. Where else we have 1000? So we have this here, but they don't actually deal with base of code. Instead, yeah, we have it here. Here we take it out of the optional header, so we don't actually need to change. Let's think if we have something else that needs to know about this stuff. It doesn't look to me like we have 0x1000 anywhere else. So let's just verify that. Good. So this is nice. But the next thing would be to try to flip around these sections. And first of all, let me try to run the test, just make sure I haven't messed up. Okay, everything is fine. We will need to turn this into something nicer, I guess, but eventually, but right now we literally just do this and this and say that our data actually comes first. And the address is going to be, so address of code is going to be 2000. And then address of entry point stays at 0. And now we change this to be 1000. Size of raw data will need to be size of initialized data eventually. But that's fine. This should stay the same. What else do we have? Technically, we don't even need to move around this code because we are just jumping to the right place. But I guess we should do that anyways. So let's take this stuff here and put it at the very end. Okay. And we need to copy this instruction or this thing that makes sure that our executable is correctly aligned. Because if we just write out these bytes, we have the situation where the size of the section will not be aligned on a file alignment boundary, and Windows will be very angry at us. So let's take text section header and just replace it like so. Okay, let me do a quick look over the stuff. So this will not actually build because we flipped around the order and now we will know this address ahead of time. So that means that we will be able to write this right away. Of course, we still need to first allocate this, then calculate the offset, but at least it is localized in here. In fact, we can like make it a block so we tell that these things actually don't escape to outer scope, and we handle all the logic locally here, which is always good. So yeah, exit process reap relative address is this, and where we did the patch, we need to do this stuff. Okay. Something like so. And obviously we need to know what is, actually this is not a libIT array, but we need to find an address of the right function. So in here, obviously later this should be something like a hash map, but for now I'll just do linear search through all of our stuff and try to find the right thing. So we go to library, in fact, where's a double loop? So we'll need to do something like this. We say S32 function or exit process pointer array is 0. At the end of the function, we want to assert that we actually found the pointer, because if we didn't, that is a compilation error. So we tried to call a function that we haven't imported, which doesn't really work. Probably this will be caught in early stages as well, but it doesn't hurt really to have extra security, especially right now, since we are in a very disjointed state with the main code that we have. Okay, so what do we do for the stuff, and we need to say if str cmp lib dll name is not 0. So here would be kernel 32 DLL. Ideally, you would want to do case insensitive compare, but I'm going to assume that we will always lowercase the names or normalize them. Maybe not, especially if we want to eventually do it for Linux where it is case sensitive, then we shouldn't do that. But at the same time, majority of libraries are lowercase, so I don't know. It's not an issue for now. So we say if it is not kernel 32, we just continue our search through the array. And if it is kernel 32, we try to figure out what is the function by doing exactly the same thing. And here we say if, so we don't need this, and we'll need to have label or loop end. I find it one of the most unfortunate things about C that you can't really break out of outer loops easier. You have to like do this. So do a goto, which is like nasty, but you have to do what you have to do. So if str cmp basically like this, but we don't continue. So if we did find it, we say that say what? So here it is case sensitive. And this is not DLL nail, this is lib functions I. What is the data structure for functions? It is the same thing. So it has a name and RVA, and the type of it is import name to RVA. Okay, so let's do that. Import name to RVA star is lib functions. So fn, put it here, put it like this. Say function name is exit process. I guess we could patch it right in there, but I do want to verify that we actually found it. So for now, I will keep this code like this, or maybe, I don't know if this is the right way to do it. Yeah, let's keep it like this for the first test run, and then I will change it to put this stuff into here. Okay, so exit process pointer RVA is function RVA. And go to loopend. Left of, yeah, this needs to be this stuff. So we subtract from the pointer our current RVA. And previously that would have been a positive number because our data section came after. Now it should be a negative number because our data section comes before. Okay, this builds. Let's see if it actually works at all. I'm honestly not sure at all. Okay, so first thing first, we didn't, I think we asserted here, but this is something we can check. So let's open dev environment, and I guess it should be mess. Let's recheck which executable we are debugging. This is the wrong one. This should be function spec. And then we do this. See, we could not open for writing. That's interesting. Who is holding it though? Let me try again. I'm slightly worried that this executes it in the wrong. Yeah, it executes it in the wrong folder. Can I specify the working directory? Yeah, so the working directory should be this. Okay, let's try again. Well, this worked, but this doesn't. But this actually crashes when we try to run the executable. Okay, this is something we can try to look at. Let's open up Pepper and see what it tells us about our executable. Does it even understand the sections? Does it understand everything? So first of all, it doesn't see the imports. That's something to think about, and I actually know why, because or I think I know why. Actually, no, we got rid of all the hard-coded stuff in here, and we got rid of this stuff. So we now say that base of code is at 2000. Not exactly sure, to be honest, what is the issue. I'm also not entirely sure if this works at all. Like maybe you have to have text section as the first one. I wouldn't think so, but you never know with Windows. Let me quickly check if I'm doing the right things. So sections, oh, so this was wrong. Yeah, so understandable that it crashed. Let's try again. It still very much crashes, but at least right now it should be doing the right thing as far as calculating the pointers to raw data. And we can even assert this, that assert our data section header pointer to raw data is 0x. What is it? We start with size of headers. So I think it will be 200, and then this will be 400, but we'll see in a second. It needs to be, of course, double equal. Okay, it does output the executable, so these things are correct, but it doesn't actually work. So size of image, this shouldn't really change. Size of headers we patch later. Section alignment, this is all exactly the same. This is going to be very interesting to debug, but we can try. Okay, so now it actually found the stuff here, and it is correct. So as you can see now, let me zoom this a bit. Now we have it at address 1000, and this is here. So this seems to be decent. Let's look at it here. That also looks pretty straightforward. Let's take a look at text section, text segment. This also looks fine-ish. I have expected to see a negative number here as well. I guess what I'll do now is I'll try to open this executable in Visual Studio and see if we can at least get assembly. Like I'm trying to understand what fails. Is it loading or is it execution? I think it's the execution that is fails, so it doesn't find the import somehow correctly. But this is something we can verify very easily by just saying debug step into. Because it's being used by another process. Yes, this stuff is using it. Wow. Let's try again. Okay, so Visual Studio and Windows were able to load the executable. However, it was not able to call this, which is unfortunate. So I can do this, right? And the problem is the pointer here seems to be bogus. But as far as its location, that seems correct to me. So I'm not sure why that happens. So if you see here, we have this address, and let me do it like this. So I expect when I subtract this stuff, so let me do it like this, and then like this, we need to address of the next instructions. So can I make it hexadecimal? Yes, that's good. Actually need to do it the other way around. Yeah, so this looks fine to me. And if you see here, this is exactly what we have. We have F1, EF, FF. So this value is correct as far as this address goes. The question is though, is this address correct? Probably can't do that. How do I? So I need to cast this to a pointer and then see what is there. Load symbols for additional information. So you can't even show me what is at that memory location? That is, well, unfortunate. Let's put it this way. Now that I'm thinking about it, it is possible that it actually has to go after, like it doesn't really load the memory there. What if I try to look at 3000? Okay. Actually, I need something like this. Let's cast it to in 6040. What type can I put here? So long or something? Can't read that address. Can you read this address? So it actually can read this address. And it is somewhere in completely different area. So what if I try to jump to it? Access violation, reading location. That is not good. Okay. What else can I do here? I guess I could be continuing to patch it as it is, even though it's not very nice. Let me recheck the documentation for this optional header stuff, because I might be misunderstanding what base of code means, and oh, yeah, there is also base of data. Is it used? Image base, that is, I think, irrelevant. A pointer to beginning of data section relative to the image base. That's interesting. So it was 0 before, which wasn't correct. Now it's still 0, which apparently might not be correct. Okay. Down, size of image, size of headers, that's fine. Checksum, subsystem, that's all okay. Might be this, probably not. Pointer to the first data directory structure in the data directory. Okay. That seems all fine to me. I'll also try to open this with Finalizer. Maybe it will give me some different information. Let's check the headers first. This all seems fine. We have IT directory address, directory size. Yeah, that all seems okay. We have two sections like this and like this. And we have imports, which doesn't see for some reason, not sure why. And the rest is, yeah, it also doesn't see, cannot disassemble because it doesn't understand code that is independent of, that's it not using image base. Okay, what can we do about this? I guess not much. It would require very deep investigation into why this works the way it works. Maybe someone else knows why it doesn't really work. Maybe I will think about something like this a bit later. For now, though, it looks like we'll have to revert majority of this stuff, But one thing that we can keep is the lookup of the right RVA here. So what would that look like? We will take this stuff. First of all, let's do it like so. And say full match found is false. We say not match found, and this, let's just avoid having this loop end, but allows us to still have assert that we actually found this. And then we say match found is true, and break. That seems fine. We need to close this stuff. Don't save. Let's try to run this. And apparently something did not work very well. Undeclared identifier. Yes, it is indeed undeclared. Instead, we should be using function RVA. Okay. Let's test. It still obviously explodes, but it is fine. I'm gonna take this, I'm gonna put it into a new file so we can get rid of our previous changes. Let's do that. Git reset --hard. And we take this stuff and we replace the code in the patching section. I might get back to this at some point, but for now it's okay. At least we will get rid of very, very hacky hard-coded things. Okay, we find the match. So since we are doing this stuff already, we actually can simplify the loop and just say that and take this strcmp here and say if, so let's take this stuff, lib functions, import name this stuff, just slightly clean up the code. Function RVA, function name. Okay, we take this stuff and we need to do another thing here where we actually check the library. This is not very efficient, of course, but better way to do it would be to attach these guys onto the imports themselves, and this is probably what we'll have to do. But let's see later on if this is the right way. For now, we'll just do comparison. So we check first for the name of the function, and if the name is correct, we also check if are we even in the correct library, which shouldn't be too bad as far as performance goes. So if we are right function, right library, then do the stuff. So take the function RVA and use that. What is wrong with you? Syntax missing, that's fine. import name to RVA star. We are missing an ampersand here. Okay, let's try this out. Well, this is interesting to know. So it might be actually that it wasn't really the switching around that broke this, because right now it is also broken. Am I pointing to the wrong thing though? I think I am. And I think that was the problem. Maybe? So let's just think about it. First, I want to do printf debugging and just make sure that we are actually here, that we found our stuff, which we didn't. Oh no, we did. Okay, so we did find it. We did some patching. We can even figure out what that was. So let's do %d and then this stuff. Let's look at it. Yeah, that looks like somewhat correct number. This is kind of interesting. Why did it not like it? Because before it was perfectly fine with it. Okay. That is very, very interesting. What I want to do now is compare it with the previous. What was it? libitrva. So let's try to figure this out. So function RVA is not the same thing as libitrva. Are we getting the right function? Function name. We are getting the right function. Okay, so what is the RVA that libiat has? And what is the function RVA? So we do, first we output these, no, this is just the setup. Then what we do is we output the names, and this RVA is an RVA of the, yeah, it's RVA of the wrong thing. It is where we are putting the information, but not where the patch will be. Okay, so that's good. That means that we actually need to store another thing, and I guess we need to extend this struct to do something else. This would be called something like name RVA, and then I need to figure out the right terminology for this. Pointer RVA or something. Sounds good to me. Let's try to build, get a bunch of errors, and start dealing with them one by one. Okay. So this is name array, name array, name array, name array. And we also have now pointer array, which is exactly the same thing. Maybe I should create a constant for this value to not copy paste it everywhere. But for now, that's fine. We have issue with, we might need to use a different type, but for now I will just hack it by not having a pointer RVA in libraries. Maybe we will need to. Okay. Maybe one of these should actually go into here. Yeah, I think this one should go eventually into this. Yeah. And this maybe should be called IATREA. But it's fine for now. Okay, this one is definitely name one. Okay. This is good. This stuff we'll have to actually get rid of. And we will need to do a different pass. So after we do this output, this is where we will do the patching separately, like we did when they were flipped. Assert match found. Okay. We don't need this stuff. All of this can go away for now. Except for this buffer stuff. This is important. And I believe this is the thing that we need to actually save. So function, where are you? Or is it the thunks that go into here? No, I think it's these guys. So this thing into here, and then function pointer RVA is function array. Yeah. So yep. And here we can do this stuff. And we can how do I want to verify that this actually works? Well, I guess I'll just printf it. So I'll printf %x of this stuff, and then I will take this, let's do it like so, and then I will also printf this stuff, and now they should match if I haven't messed up anything. So here we are pointing to name RVA and name RVA. And another name RVA. Okay, let's try this version. Okay, this version works, which is very, very promising. And yeah, we actually have a match. The reason there are two, so we are interested in this address, not in this one. There are two libraries and kernel 32 is the first one. So this is all fine and it's verified by the fact that our executable actually works. Let's save this state, but also that means that we might be able to actually do what I wanted to do originally, which is swapping around this stuff. Let's try that one more time. We have this stuff here, that's fine. Again, let's put it into a block, put this stuff here. Like so. This is good. We flip around these two things. We put 1000 here. Then we flip around these two. Would be nice if we didn't have to do it, but that can come as a separate refactoring. We wanted to change the size of initialized data, and then we need to change base of code and address of entry point. I believe that would be all the things that we need to change. Yeah. Yes, now we actually need to move this stuff to the bottom. And as before, copy this stuff around. And say that text section header is this. Okay, moment of truth. Does this work? And it does. Great. That is great. Whew. This is exactly what I wanted to get to in this video. It took a bit of a roundabout way because it is basically impossible to debug this stuff, as you saw, like, it just doesn't work. How do you do this? But doing it step by step actually ended up being the right thing. So that's very nice. The fact that we now have this here, as Ted mentioned, it means that we no longer need to kind of store some data somewhere and then do an extra patch. We are just outputting all the headers and gathering up together. And when we want to output an address for our stuff, we just do that. In the next video, gonna get back to actually generating assembling, or more precisely, we will generate these things here. So I want to get to having this coming from our main code. So we would just have a macro or something that says, I want to import this function from this DLL, and it would generate one of these structures that we then can use here, which would be pretty neat. And eventually, when we have our stuff that generates the code, we'll just have probably a special type of operand, or maybe not, maybe it will be directly like a rip relative stuff. So essentially, whenever we see global data, we'll just shove it into that section, and we know that inside of executables, that section will go before our code section. So like those offsets will not actually change, which is pretty nice. Yep, I think that would be all for today. Thank you very much for watching, and hopefully see you next time.